Okay, so as we saw, the C++ is going to use the default assignment operator unless we define our own. So on the right-hand side over here, you see the defined assignment operator for the safe array class. If it exists, it uses the one that's defined for the class. Now let's recall what we need to do over here. We want to make sure that the problems we have with the default one don't happen. What are the problems? The first is that we're going to have the memory leak on the left-hand side, because when we copy over the pointer from the right-hand side to the left-hand side, we copy from there to there, so it's going to delete this pointer, and this will be a memory leak over here. That's a second problem, the first problem. The second problem is that the A and B got conjoined. When we say A is equal to B, since they're going to end up copying, if I use the default assignment, I'm going to end up copying the memory from here to here, from B to A. And then what happens is they're changing A changes B and vice versa, and that's not right. And the third thing was the problem of going out of scope and destroying the common memory. So in order to solve that, what we really want to do is when we copy B into A, what we want to make sure is that A has its own copy of the data, so that changing A's data will not change B's data and vice versa. But before we do that, we have to make sure that we return the memory on the left-hand side. We go back to the heap and give this back so we don't have the memory leak. Once we do that, all those problems are going to be solved. Let's see how this thing works. And it's going to use this this pointer later on, as we just talked about earlier. So let's take a look at the operator equal itself. So first of all, to recall the following. When we say A is equal to B, when we assign B to A, the compiler changes this to A dot operator equals of B, right? So B is the right-hand side and A is the left-hand side. And that's the way we write it. And in fact, what happens is the compiler then retranslates this to A dot operator, it has that extra operator equal, and then passes the address of A as the first parameter and B. We don't write the second one, the compiler writes this. This is the one that's going to go into a parameter. Over here you'll see we have a parameter S, so B is going to go into the parameter S, and the address of A is going to go into that parameter that the compiler created for us, called this. Okay, let's take a look at the function line by line. Let's skip the first line for a moment. We'll come back to that. We'll go to the second line, which is the delete. So the first thing we want to do here with the delete is we want to make sure we don't get a memory leak. So we say go to P. What is P? When we use P by itself, we mean the P of the left-hand side, A. Go to A, the P, the pointer P on the left-hand side, and delete what it points to. So what that's going to do is it's going to take the memory over here that it had before, and it's going to get rid of it. Now that's not a problem. That's exactly what we want. Even though the 10, 20, 30 are going to be lost, that's what you mean by assignment. You wipe out what's on the left and you replace it with what's on the right. So what's going to happen is the guy on the left, this stuff over here is going to disappear. The whole memory over here is going to disappear. Now P will still have the address of what it was, but it's not going to point to anything that we can get at. The second step over here in the function says figure out how much memory the array on the right-hand side has. Now how do we figure that out? So we have s dot high. What is s? S is the parameter, right? S is the is b. So we say, well, take the high of b minus the low of b plus 1. That gives us how many spaces it has. Call that size, and then go off to the memory manager, the next step over here, and ask for size integers, right? New int size. Get size integers. In this case, we're asking for 1, 2, 3, 4 integers. So it's going to find those 4 integers. And it's going to be different than these on the right hand. It just looks for 4 new spaces. We just use size to figure out how many there were on the right hand side, but it's going to give us new memory. And it's going to take new is going to return the address of where it found those things. And then we're going to say put that into, so we have now 4 new spaces in the heap. And we're going to assign that to P. When we say P by itself, we mean P on the left-hand side. So now P is going to point to these new memory. Now what we're going to do is, since we want to have a copy of the data on the right, when we say A is equal to B, we want A to be a copy of what B is. So we're going to go over to B and copy element by element. We're going to go copy the 1, the 2, the 3, the 4 into the left-hand side. How do we do that? Well, since P is pointing to the P here is P is pointing to an array in the heap, we just simply say P sub I right? The left-hand side is equal to s dot p sub I. That's what happens over here. So p sub I is the array on the left. S dot p sub I is the array on the right. So we go from 0 up to size minus 1. And so that's going to copy a 1, a 2, a 3, and a 4. So at this point, what we have is we have copies of the data. A has its own copy of the data, and B has its own copy of the data. Now what's left? We have to adjust on the left-hand side on A, we have to adjust the lower and upper bound. So that's what happens in these next two statements. The low on the left-hand side gets s dot low, which is low on the right-hand side, so the 0 gets copied into the 0. And then the s dot high, which is a 3, that gets over here, so this is no longer going to be a 2, it's going to be a 3. And basically we've reconstructed the array on the right-hand side into the left-hand side. So that's how we say A is equal to B. Now what about the return type, right? What does this thing say here? Return star this. So what does that mean? Well, star this, well, what is this? This is the address of A. Well, whenever we have an address, in this case we have the address of A, when we dereference an address, of course, we get another name for the object that the address points to. So since this points to A, right, that's what it means, this points to A, the left-hand side, star this is another name for A. So what we do is we return, and you look at the top, we return a safe array reference, we're returning an address to A. Now why in the world would we want to do that? And the answer is because we want to be able to do chaining, just like we saw in overloading the output operator, the left shift operator. If I want to say something like A is equal to B is equal to C, right? I can do that in C++. I can say, for example, for built-in type, I is equal to J is equal to K. I want to do the same thing for my safe array. Now, how does assignment work? Assignment works from the right to the left. First it says K goes into J, and then J goes into I. The way it works is when I say K goes into J, what gets returned? Assignment operator. What gets returned is, right, it actually returns something here. Not only does it do the assignment, basically what happens is I get J back. I get the name J back. When I say J is equal to K, the name J comes back. And then when I say I is equal to J, it says whatever's in the J goes into I, and I get the name I back. Right? That's the way assignment works. That's the definition in the language. When I say X equals Y, it causes the bits in X to match the bits in Y, but it returns the name of the object on the left-hand side. So that's what I have to do. Remember we said you have to do as the ints do. This basically gets translated into, well, first I do B is equal to C, and so what happens then is that's going to be B dot operator equals, and it's going to do C. Now what happens here is it's going to do that assignment as we saw, and this is going to return the left-hand side. This is going to return B. That's what's going to come out of here. I'm going to get B out of here, and then it's going to say A dot operator equals of what comes out of doing that. So that's going to be the B. So in order for that to happen, in order to get that chaining, since I have to have, if you look what the parameter is, the parameter has to be the name, has to be a reference. Look on top again, right over here. It has to be a reference to an array. So in order to get the chaining, when I say A is equal to B is equal to C, when I say B is equal to C, it has to return a safe array so I can pass it in once more to A dot operator equals, right? So therefore it returns this safe array B, which is the safe array B after the assignment, right? After I do C goes to B, and so that's why it has to return a safe array reference. Now the very, very last thing is that first step that we left out. Let's just take a look at that for a second. Notice that let's say I and J are integer variables, right? Let's say, is it legal? Of course it is, to say I is equal to J. That's a regular assignment statement, and it takes J and it copies it into I. Now what about the following? Is it legal to say I is equal to I? Well, it's not accomplishing much, right? But it certainly is equal. It certainly is legal. I can have self-assignment. So since the rule is going to be that my assignment operator for my new classes have to do as the ints do, I have to be cognizant of the possibility that somebody using my class can do something like this. They can take a safe array A and say the safe array A is equal to the safe array A. Now that sort of looks harmless, if a little bit dumb, but it's actually not harmless, because if we come back over here, let's check what happens in the code for the assignment operator. What's going to happen if somebody does that? So look over here. the first thing, if we don't, again, we're going to look at this in a moment. The first thing that happens is that I say delete P. So it's going to go to the left-hand side, right, which is A, and it's going to delete the P of A. But then it's going to try to copy the P of the right-hand side, but that's the same A, so it's going to try to copy deleted memory, and that's disastrous. It can't do that. So if the left-hand side is equal to the right-hand side, this whole thing is going to be one big mess up. So we have to make sure that we take care of this case so we don't mess things up. And that's what this first statement does. This first statement says the following. It says, is it the case that if this is equal to the address of S? Now, what does that mean? Well, what is the address of S, right? The address of S is the address of the object on the right-hand side, right? Because S is the parameter that I pass in. So when I say A is equal to B, for example, S is the address of B. This, as we saw, is that special parameter, which is the address of the left-hand side, which is the address of A. So if A and B are two separate objects, like they are over here, the answer is no, it's not the case that this is equal to the address of S, right? We come over here. Then we don't return star S. We just simply go and do the rest of the function as we saw. That's going to be fine. But what happens if I say A is equal to A? Not A is equal to B, but I say A is equal to A. When I say A is equal to A, so this on the left-hand side is going to be the address of A. The right-hand side, the address of S, is going to be the address of A. In that case, we don't want to go through and do this because that's going to mess everything up as we saw. What we simply want to do is return. I'm not going to do anything because there's nothing to do, but in order to guarantee that we don't mess anything up, we simply return. And what do we return? We return star this. What's star this? That is the name. Remember, this is an address. Star this dereferences that, gives you the name or reference to the left-hand side. So saying A is equal to A basically returns A. What does that accomplish? Because if I say A is equal to A is equal to B, so then it's going to do A equal to B appropriately. It's going to return A. And then when it tries to do A equal to A, it's going to simply return the A on the left-hand side without doing anything, and everything is fine. That is how assignment works for the Say4A class. And this is not only going to be useful here, this is really the case. Anytime my object has pointers, you're going to have the same kind of situation, and we're going to really have to take assignment into our own hands so that things don't get messed up by using the default assignment.